Hey guys, welcome to my channel. In today's video, we are going to explore an efficient approach to handling data in .NET applications by combining two powerful tools, Entity Framework and Dapper. You might be wondering why use both. As you know, EF is known for its ease of use when it comes to complex data operations like creating, updating, and deleting records. But sometimes, especially in read-heavy applications, it can be a bit slower. This is where Dapper comes in. Dapper is a lightweight and fast ORM designed for optimized reading of data. So in this video, I'm going to show you how to split responsibilities between EF and Dapper in a clean architecture. We will use EF for handling the creation, updating, and deletion of records, and Dapper for fast and efficient reads, giving you the best of both worlds. By the end of this video, you'll understand how to structure your project, set up both EF and Dapper, and integrate them smoothly into an efficient data access layer that balances performance with simplicity. If you find this video helpful, don't forget to like and subscribe to my channel. Hit the bell icon so you won't miss any future tutorials. Also, you can download the complete project from my GitHub account. I've provided the link in the description below. Now let's dive in and break down each part step by step. Okay, this is our project. I've implemented this project with clean architecture. This structure is simple, clear, and follows best practices for maintainability and scalability. It's great for large applications, but our main focus today isn't on the structure itself. What we are really diving into is how to use both Dapper and EF Core in this project to get the best of both worlds, maximum performance and flexibility. Before we get into the details, here's a quick overview of clean architecture for those who might not be familiar with it. We have split the project into layers: core, application, infrastructure, and the API. Each layer has a specific responsibility, but don't worry, we are not going to spend much time on these details today. The main goal of today's video, as I mentioned before, is to show you how we have used both Dapper and EF Core in this project and how you can dynamically switch between them based on your needs. This gives you the flexibility to leverage Dapper's raw performance for reads while still using EF Core's rich feature set for more complex operations like creating, updating, and deleting data. Now here's an important part. We are using Kit services in .NET 8 to make this happen. This is a new feature that makes it super easy to switch between different implementations of the same service based on a key. So make sure you have installed .NET 8 on your machine because this feature is only available in .NET 8 and above. If you don't know much about Kit services, I've got another video linked in the description where I go into detail about this feature. So definitely check that out if you are curious. Now let's break down the project and I'll show you how it works. The core layer is the foundation of our project. It contains the business logic and domain entities that define the rules of the application. In this layer, we don't depend on any external frameworks like Entity Framework or Dapper. It's all pure C#. Here's entities are the objects that represent the data model in your domain. In our case, we have the product class, which might look something like this. The product entity is part of the core logic. It represents what the product means in our business. The core also defines contracts or interfaces. For instance, we have the iProduct repository interface. This interface defines the operation we need for handling products, but it doesn't care how we implement those operations, whether it's through Entity Framework, Dapper, or any other data access method. The key takeaway for the core layer is that it's completely independent. It has no knowledge of external dependencies, and this makes it very flexible and easy to maintain. Next, we have the application layer. This is where we handle all the business use cases and application-specific logic. The idea is to abstract away the infrastructure details and focus on the what rather than the how. Here we implement the service classes that call our repositories. In our case, we have the product service class. Notice how the product service doesn't directly interact with the database. Instead, it uses iProduct repository interface. It also uses Kit services to dynamically select which repository to use EF Core or Dapper based on a key. The application layer focuses on handling the business flow, making decisions about which repository to use and how to handle data processing. But it still doesn't care how the data is stored or fetched. Now let's talk about the infrastructure layer. This is where we handle all the details about how data is stored, accessed, and manipulated. In our case, we have two different implementations, EF Core and Dapper. EF Core repository uses Entity Framework Core to interact with the database. EF Core is a powerful ORM that abstracts away raw SQL and allows you to work with data using C# objects. Dapper repository uses Dapper for data access. Dapper is much more lightweight than EF Core. It directly executes SQL queries and maps the result to C# objects. This makes it faster in certain scenarios, but require you to write the SQL query yourself. The infrastructure layer is all about the how. How do we store, retrieve, and manipulate data? Here we are not only using EF Core and Dapper, but also managing connections and queries specific to our database. Finally, let's talk about the presentation layer. This is the layer that interacts with outside world, specifically through HTTP requests. In a typical ASP.NET Core application, controllers handle incoming requests, execute business logic, and return responses. Here's an example of the product controller. Product controller uses different routes to handle EF Core and Dapper requests separately. For example, create product API create a product using EF Core, while get all products API fetch products through Dapper. The controller doesn't know or care about repositories. It interacts with the product service, which handles all the data fetching logic. This keeps the controller clean and focused on handling HTTP requests and responses. The controller is essentially the entry point for the client, allowing interaction with the application through API endpoints. It calls into the product service, which in turn accesses the database using appropriate repository. This is just a reminder that you need 4 packages to implement Dapper and EF through Kit services. The packages related to Dapper and EF are installed in the infrastructure layer, and the package related to Kit services is installed in the application layer, because you need to use get required Kit service method, and for this method you need the Microsoft.extensions.dependency injection package. Also, don't worry at all, this project is available on my GitHub account and you can visit and download it anytime you want. Just remember it, to use this project, you must have .NET 8 downloaded and installed on your machine. Alright, now let's check the most important part of the project. We are using both Dapper and Entity Framework Core at the same time in this project to get the best performance for different database operations. The reason for this is simple. Dapper is super fast when it comes to reading data, making it perfect for queries where performance is critical. On the other hand, EF Core is great for managing more complex operations like inserts, updates, and deletes, where its powerful change tracking and built-in validation come in handy. So combining the two gives us the best of both worlds. Now let's talk about the iProduct repository interface. Both Dapper product repository and EF Core product repository implement this interface, but each one focuses on different parts. The Dapper repository is responsible for the read operations, while the EF Core repository handles the create, update, and delete operations. This separation allows us to optimize performance where it's needed most. Also, we use Kit services in .NET 8 to register our iProduct repository implementations. In the program.cs file, we register both the Dapper and EF Core repositories like this. With Kit services, we are telling the app to register both repositories, but to use a key to decide which one to use at runtime. This gives us the flexibility to switch between repositories dynamically based on what the application needs at any given moment. In the product service, we use the getRequiredKit method to decide whether to use the Dapper or EF Core repository depending on the operation. This allows us to pick the right repository on the fly and gives us a super clean way to handle database operations efficiently without hard coding any decisions. So by combining Dapper and EF Core and using Kit services, we are making sure that our application performs well on the data retrieval side while keeping things simple and robust for create, update, and delete operations. It's all about using the right tool for the job. And remember, if you are not familiar with Kit services, I have a full video on that, so be sure to check it out if you are interested. Alright, let's dive into another key part of this project, the database and how we set up it. First off, we are using a SQL Server database for this project. To connect to the database, we store the connection string in the app settings.json. Here's how that looks. In this file, we define the default connection, which contains all the details needed to connect to the database, like the server name, database name, and login credential. You will need to update this with your own SQL Server information. Now, to make sure that our application can use this connection string, we need to register it in the program.cs file. This is where things come together. In program.cs, we read the connection string from the app settings.json file and make it available for EF, Core, and Dapper to use. Here's how we register it. Now let's talk about the product controller and how everything comes together when we are switching between services using the repository key. Now you are probably wondering how we decide which ORM to use for each action. This is where key services come into play. In the product controller, we inject iProduct service, but behind the scenes, we decide which repository to use based on the repository key. Here's the magic part. For reading data, we use Dapper. For creating, updating, and deleting data, we use EF Core. How do we do this? We pass the repository key to our product service. Depending on whether the key is Dapper or EF Core, it switches the implementation. Here's a quick look. By default, if no key is provided, Dapper is used for reads and EF Core for writes. But you can override this by simply passing a different repository key in the query string. Pretty flexible, right? Now let's run the project and test it out. First, set a breakpoint in the get all products endpoint. When you hit that with a get request, you will see that the Dapper repository is being used to fetch the data. Next, set a breakpoint in the create product endpoint. When you send a post request to create product, it will use the EF Core repository for the database interaction. You will be able to trace the entire process switching between the repository effortlessly, all thanks to Kit services. And just like that, we've built a project that optimizes both read and write operations by using the best features of Dapper and EF Core, switching between them with a simple key. Alright, we are at the end of this tutorial, so now you have seen how we can combine the power of Dapper and EF Core in a single project using Kit services. It's a clean, efficient way to handle both reading and writing operations in your applications, and I hope it's been helpful for you. Don't forget, you can download the full project from my GitHub account. I've put the link in the description below, so feel free to check it out, clone the repo, and play around with the code. If you found this video useful, please consider liking the video, subscribing to the channel, and hitting that bell icon so you don't miss out on future tutorials. Thanks for watching, and I'll see you in the next video. Cheers.